Hello everyone, welcome back to my YouTube channel. In this week video, I'm going to explain to you how to answer 3 different numerical questions associated with chapter 5. So let's get started. Question number 1. An X-ray of wavelength of 0.25 times 10 to the power of negative 10 meter are diffracted by 220 plane in a gold crystal at an angle of 5 degrees in the first order. Determine the lattice constant of the cubic unit cell. Alright, so the formula that we can use to answer this question is n lambda is equivalent to 2d sine theta. Right, so let's look at the question. So you were given the theta, which is 5 degrees, the lambda, 0.25 times 10 to the power of negative 10 meter, and also the value of n, which is the first order. So now what we are going to do is we are going to plug in all the values given in the question. So n is equivalent to 1, lambda is equivalent to 0.25 times 10 to the power of negative 10 meter, is equivalent to 2d, which is the thing that we are going to calculate, and sine theta. Your theta is 5. So basically, 2d is equivalent to 0.25 times 10 to the power of negative 10 meter divided by sine 5. Right? So you will get 0.25 times 10 to the power of negative 10 meter divided by 0.08715. Therefore, your D shall be equivalent to 2.8686 times 10 to the power of negative 10 divided by 2. And you will get the value of D is equivalent to 1.4343 times 10 to the power of negative 10 meter. Right, so in the question, you were asked to determine the lattice constant of the cubic unit cell. Means that you were asked to calculate the value of A. So we need to use the value of D that we have calculated just now and plug in into another formula. Right, so just going to recap, the value of D that we have calculated just now is 1.4343 times 10 to the power of negative 10. So this value of D, we have another formula which is equivalent to A divided by the HKL. So square root of H square plus K square plus L square. Alright, another thing that were given to you in the question is that it is diffracted by 220 plane. This 220 is actually the value for the HKL. So in other words, we need to plug in the value of D, 1.4343 times 10 to the power of negative 10 is equivalent to A divided by the square root of HKL. So your H is 2 to the power of 2 plus K is 2 square and L is 0 square. So it's equivalent to A divided by the square root of 8. Alright, so what is left for us to do is to find what is the value of A. So the value of A is equivalent to the square root of 8 times 1.4343 times 10 to the power of negative 10 meter. Therefore, you will get your A is equivalent to 4.0568 times 10 to the power of negative 10 meter. So this is actually the lattice constant for the cubic unit cell. So the final answer for this question. Question number 3. X-ray of an unknown wavelength are diffracted by a silver sample at second order diffraction. The 2 theta angle was 64.582 degree for the 101 plane. What is the wavelength of the X-ray used given that the lattice constant of silver is 0.40788 nanometer? In this question, we were given the plane of the crystal, which is 101, and we were given the lattice constant of silver, which is 0.40788 nanometer. Therefore, we can use this information to calculate the value of D. So D is equivalent to A divided by the square root of H square plus K square plus L square. So this value is from the plane. So the value of A is 0.40788 nanometer. Since it is in nanometer, we need to convert it into meter. Therefore, we need to times 10 to the power of negative 9. So we need to divide with the HKL. Your H is 1 square, plus K is 0 square, plus L is 1. So 1 square. Therefore, we will get 0.40788 times 10 to the power of negative 9 divided by the square root of 2. Right? So you will get the value of D is equivalent to 0.40788 times 10 to the power of negative 9 divided by 1.4142. Hence, your D is equivalent to 2.8842 times 10 to the power of negative 10 meter. Right, so since we already got the value for D, now we can move forward to calculate the wavelength of the X-ray. So in order for you to calculate the wavelength, you need to use the formula, and wavelength is equivalent to 2D sine theta. So what is your theta? It's already given to you in the question. But remember, in the question, you were given the 2 theta. So your 2 theta is equivalent to 64.582 degree. Therefore, your theta is actually 64.582 divided by 2. Right? So it should be 32.291. So don't forget to divide this into 2 because you will only need to use theta, the value of theta, not 2 theta. Alright. So, and then in the question also given here that the sample at second order. So your N is 2. So your lambda is the one that you want to calculate. Your D is this value here that you have just calculated, times 10 to the power of negative 10. So make sure that this one is in meter, alright? So sine this value of theta. Okay, so you can find your lambda is equivalent to 2 times 2.8842 times 10 to the power of negative 10 meter sine 32.291 divided by 2. Right? So therefore your lambda should be equivalent to 3.0815 times 10 to the power of negative 10 divided by 2. Hence, you will get your lambda equivalent to 1.5408 times 10 to the power of negative 10 meter. Right. So this is the final answer for the third question. We have come to the end of this week's video. Thank you very much for watching this video from the beginning till the end. I hope that this video will help you to understand more on how to answer numerical question from chapter 5. So I'll see you again next week. Thank you very much. Stay safe. Goodbye.